Okay, so now what we're going to do is use the same information that we had before, but now we're going to write our equations of momentum, conservation of momentum. So let's see what we got here. Let's call this one 1. That is a 1, believe it or not. Call it 1, position 2, and position 3. All right. So first of all, I want to write the conservation of momentum. Let's do it for part A from 1 to 2. Okay. Come here. From 1 to 2. All right, so we start off with MA VA1. Okay. So we have VA1. And then what happens? Let's see. This other guy pushes on us, right? If this is he's being pushed on by that, negative P integral. So he gets pushed on to smush. And then in the midpoint, he's going to be at constant velocity, V. MAV. Good? Good. All right. Now if we go from 2 to 3, he's going to start at MAV. And then what happens? He gets smushed on, or he gets restituted or unsmushes at minus R, and then he ends up at VA2. Okay, so we have this minus R, minus R, VA2. Okay. So now what I want to do is I want to look at the ratio of unsmushing to smushing. Okay, now the reason I want to do this is how much I pop out, right? This is how much I pop back out, and this is how much I smush. Now, if we decide that this number on the bottom is always going to be bigger or equal to the top, in an ideal situation, it'll be equal. So this ratio will always be less than or equal to 1. So that's the reason we set up this ratio like this, is because, you know, we can scale it from 0 to 1. So, I mean, we could have just as easily done this, but then, you know, our number could have gone from 0 to 100 million or whatever. So we're going to look at this specific ratio because it will always be less than or equal to 1, and again, between 0 and 1. Okay? And this ratio actually has a special symbol, and it's called E. So this is equal to E, and E is called our coefficient of restitution. It's another reason that restitution is on top, is because we call it the coefficient of restitution. Okay, so let's take a look again here and see how we can get that. So I'm going to go ahead and solve this for P. That's going to give me MAVA1 minus MAV. I don't know why I put it up there. That doesn't make sense. All right. And then this one here is going to become MAV minus MAVA2. Okay, so now I can divide them by each other and get my coefficient of restitution. E will be equal to R over P. R over P, yeah. So R over P. Okay, good. Now, I think without too much of a stretch of imagination, you can see that if I was going to do this for B, I get the exact same thing, except everywhere I have an A, I'd put a B, right? So B is similar. So go prove that to yourself if you're not sure. Don't take my word for it. So I'm going to say that MB, V minus MB, VB2, you know, we could look at either one, basically, is what we're saying. Not A, MB, VB1 minus MBV. Yay! Okay, So, now the fun part of this is the algebra. So, now for some algebra. Can't spell. algebra. Okay. So let's see what we can do with this. Since these are equal, we can cross multiply. So let's do that first. Because, I mean, why not, right? Okay. Oh, before I do that, actually, I can make it pretty. What can I do? Oh, I can factor an MA and an MB. All these MAs come out, right? Because I can factor them. Oh, that'll make things much prettier. All right, let's try this again. So the coefficient of restitution, V minus VA2, VA1 minus V, V minus VB2, and VB1 minus V. Now, your book might have this, if I'm not mistaken. But remember, I can just multiply the top and the bottom by -1, and it'll get the previous one, and the negative ones cancel. So they're the same thing. So don't get too nervous or bent out of shape about that. But now we can. Let's go ahead and go ahead and cross multiply. Okay. So I've got V, yay, VB1 V minus VB1 VA2. That's okay, I can do this. Minus V squared plus VA2V. Okay. And that's going to equal VA1V minus VA1VB2 minus V squared minus plus VB2V. Alright, and these cancel out. Now let's try to fit this all in one little line so you can see it, see what I'm doing. Okay, that was fun. Alright, let's see, what can I do next? That's a great question. I can put all my V's on one side. VB1 plus VA2 minus VA1 minus VB2 equals VA1 VB2 minus plus VB1 VA2. Oh, isn't that beautiful? Okay, so I got an equation for V. Now I'm going to plug that back into my coefficient of restitution. So for V, I'm going to plug in this VB1 VA2 minus VA1 VB2 all over VB1 plus VA2 minus VA1 minus VB2C. You don't actually have to do all this, but you know, it's good for you. Minus VA2. And I don't want to write this again. Copy. And this is going to be VA1 minus paste that. Alright. Isn't that exciting? Yay. You can't see what I'm doing anymore. That's because it's a secret. Just getting this stupid thingy out of the bottom. Fraction. And keep working through, blah, 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 blah. So E equals, that's going to cancel on the top. VB1, VA2. When am I ever going to need to know algebra? All the time. Minus VA2, VB1, minus VA2 squared, minus VA2, VA1. Please let this work out. Plus VA2. What 2 is that? Oh, this is a B. VA2, VB2. Root all over. VA1, VB1 plus VA1, VA2 minus. That's what I have to say about that. Yes, I just blew a raspberry in the middle of class. Minus VA1, VB2. And then Got to remember to apply that negative sign. Minus VB1 VA2 plus VA1 VB2. Alright, that was awesome. Did you have much fun as I did? Alright, good. B1, A2, do I have any more of those? No. A1, B2s? Yep. This is not boding well, is it? I should have an A2, B1. Oh, I do, right here. A2, B1s. Look, those go away. And then A1, B2, go away. Should I make that smaller so you can see the whole thing at once? Would that be helpful? Because I can see it. Really? That's all equal to E. But you still can't see it. I keep forgetting how tiny your screen is. Okay, so that's E. Okay, it's a full service issue here. We're going to give you everything you could have ever wanted. Alright, now believe it or not, I believe I can factor this. What if I pull out a VB2 out of the first one? Let's see, that'd be VA2 minus VA1. And then if I pull out an A2, I've got a VA2 plus VA1. Did I miss a minus sign somewhere? Yeah, that's supposed to be a positive. We'll get there eventually. And then that makes that negative. I think we're good. Yeah, I think that's what I want. And now I keep making progress. Pull a VA1 out. You see where this is going? Woot! And now, very, very thankfully, all those cancel out. And I have with us an epsilon that is VB2 minus VA2 over VA1 minus VB1. And this is our coefficient of restitution, as exciting as it is. So on this, you really want to be careful with your signs, because here the B is in the front and here the B is in the back. So it really doesn't matter, because you could say this, and that's going to be the same. It's just off by negative on the top and the bottom, so it all comes out the wash. You just need to make sure that you're consistent with how you do this. So that gets you the derivation of the coefficient of restitution. And now we're actually going to talk about what we can physically do with this.